In these set of notes, we're going to talk about a specific type of polygon and finding the area of them, and that is a regular polygon. So if you remember from before, a regular polygon means that all the sides are congruent and all the interior angles are also congruent. So in the figure on the right, this diagram shows a regular polygon, and it is inscribed in a circle. That means the circle goes all the way around the outside, and if you notice that it touches all five of our vertices. The center of the polygon, so that's my point F right there, and the radius of the polygon are the center and the radius of the circle. So that means that they are the same thing. So the center of my polygon is F, and it's also the center of my circle. The radius of my circle would be from F to A or F to B, and that's also the radius of the polygon. So point F is the center of our polygon. It's also the center of the circle, and the radius is BF, and it's also AF. So just depending which side you look at. So next, the distance from the center to any side of the polygon is called the apothem. The apothem is the height to the base of the isosceles triangle that has two radii, and radii is plural for a radius, as the legs. So when we look at our picture right here, this part in blue is the apothem. So if you notice that we have a triangle, so if we drew, we would have 5 equal triangles in our pentagon, and the height of that triangle is the apothem. So the part in blue is our apothem, so that would be GF. All right, so the central angle of a regular polygon is an angle formed by 2 radii, so that's our parts in red right here. To find the measure of each central angle, we're going to take 360 degrees, that'd be all the way around in the circle, and divide it by the number of sides. So in our picture, our angle BFA is our central angle, so that's from right there. And if we were going to find the degrees of that central angle, we would take 360 and divide it by the 5 sides, and that would give us 72 degrees is how many degrees that one angle would be. So if you notice, this picture is the same as the picture we had just seen, and we want to find the different angles created by the center F. So if you remember, we're going to take 360 divided by the 5 sides, and we get 72 degrees is our central angle. So AFB is that whole angle, and that is 72 degrees. All right, so moving on to the next one, AFG, choose colors, this is orange now, that it is going to be half of that angle because our apothem bisects the central angle. So what that means is that we can divide that in half, or divide it by 2, and we get 36 degrees is that orange angle. So next, we want to find the angle GAF, and that would be right here in blue. So it's our missing angle right here is what we're trying to find. Since we know that GAF, that angle, is created by the triangle GAF, so think of the whole triangle, we know that the whole triangle starts at 180 degrees, and if we subtract off the 90 degrees that we already know for the right angle, we can subtract off the 36 that we already know, and then what we have left over is our angle that we are trying to find. All right, so the next picture is a square that's inscribed in a circle, and we just want to label and identify the different pieces. So first is our center. Remember, the center is the point P, and they share that point so that it's the center of the square and it's also the center of the circle. Next, we have the radius, and just like before, think of the circle. The radius connects it to the outside of the circle, so that would be these 2 lines, so PX and PY. All right, next we have the apothem. So remember, that's the height of our triangle created, so that's PQ. And then lastly is our central angle again, using those 2 radii, so angle XPY. And if you notice, the center letter has to be the center of our shape so that it is that we just don't forget that that has to be the center letter for the central angle for your 3 letters. All right, so now we're going to get into finding the actual area of our polygons. So we have to know those different vocab words so that we can use them in this formula. So the area of a regular n-gon, so that just means that it can be any number of sides, that we need to take half of the product, remember we multiply, of the apothem and the perimeter multiplied together. So we're multiplying lots of pieces together. So we're taking 1/2 and then times A times P. So A is the apothem, and then P is the perimeter. So we're taking the number of sides and we're multiplying it by the side length is what you want to think of for the perimeter. All right, so in our table picture down below, I'm going to give you a new measurement to add in, because really in our picture when we draw this triangle and they give us a side of the triangle, but we need the apothem. So the apothem you will always be given, so draw this blue line in there with a right angle because we know that's what makes it at the apothem. So my apothem is going to equal 7.5. So just assume that I've already given that to you because I just needed to give that to you in the problem. All right, so our apothem is going to be the 7.5. The perimeter, remember we need to take the number of sides of our figure and multiply by the side length. Well, the number, or the side length, is this 15 inches. And if you count up the number of sides, we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 sides. And if we multiply those together, we get 120 inches. So now we can go ahead and set up our equation right here. So A equals our 1/2 times our apothem, so 7.5, times the perimeter, so that would be 120 inches. So now we can type this all in the calculator. We can type it in all at the same time, so you don't have to separate it out. You'll get 450 inches squared would be the area of this whole table. So here are 3 practice questions to practice just filling in all the places for our area of a regular polygon. So we have to know how many sides there are, remember, and we want to list out all of our pieces. So we're going to list out our apothem, and that's our 15.5. I don't know if you can see the decimal, but I'm going to make sure that you can see it. So it's 15.5. The perimeter then, where we take the side length, so 11.3, and I need to multiply that by the number of sides. And in this figure, I have 9 sides. And if you do not trust me, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so when I do that, I get 101.7. So that's my perimeter. So now I can just go ahead and start filling everything in. So I've got 1/2 times, and I suggest you use parentheses because there will be a lot of decimal numbers in here. You might mistake a decimal for a multiplication symbol or vice versa. So times are 101.7. All right, so when we type that all in the calculator, I get 788.175, and we don't have any units on here, so we're just going to write units squared. I would rather have you write unit squared, like the word unit squared, than leave nothing on there for the area. So just try to find some type of units to put with your answer. All right, for the next one, our apothem, where is the height of the triangle that's created. So my height is the 14. My perimeter then, I'm taking my 20.4. And in this one, let's see, we have 1, 2, 3, 4, 5 sides. So when I do that, I got 102. So let's set it up. 1/2 times my apothem of 14 times the perimeter of 102. And if we type that in the calculator, we get 714, and that's units squared again. All right, for the last one, our apothem is 12.5. Perimeter, we should take our side length, so 12, times, and this one, let's count them up. We've got 1, 2, 3, 4, 5, 6, 7 sides. So it's a heptagon, if you remember your words before. And that gives us 84. So then for our area, we can take that 1/2 times the apothem, so 12.5, times my 84. So I get 588, and again, it would just be units squared. So realize you're going to be using this formula when we get to the next section, so we're going to be getting to probability for the next video. So you want to know these areas really, really well so that when it comes to those problems, you can do this pretty quick.